Good morning to all of you. Myself, Dr. Jitendra Kumar Narwal, Assistant Professor in Chemistry, JMGR College, Dadri. Today topic on physical chemistry, the chemical equilibrium. It is generally observed that many reactions do not go to completions when they are carried out in closed vessels. In all such reactions, in the beginning, that reactant gets changed into the product. But after some time, the concentration of the reactant does not decrease and reaction appear to have stopped. And this state of system in which no measurable changes occurs, this is called state of equilibriums. And when the equilibrium is attained in the physical process is called physical equilibrium, for example, the evaporation of water. And when the equilibrium is attained in the chemical process is called chemical equilibrium, for example, the decomposition of the pentachloride. So first topic is the state of chemical equilibrium. State of chemical equilibrium. Consider a general reversible reactions. Consider a general reversible reaction AA plus BB, reversible reaction CC D. And from the graph, this is the graph, here is this rate of reactions and this time. This is the forward reactions and this is the backward reactions. This is the rate of forward reactions and this is rate of backward reactions, and this is the equilibrium state. Equilibrium state. As the start of the reactions, that reactant A and B react to form the product, and with the passage of the time, the concentration of the reactant decreases and rate of forward reaction also decreases, and the concentration of the product also increases with the passage of time, and rate of the backward reaction is increases. A stage is reached when the rate of forward reactions become equal to the rate of backward reactions and the system attain the equilibriums. And a state of this equilibrium is the state in which the measurable property of the system do not undergo noticeable change under given set of conditions. That is the property, temperature, pressure, concentration, all of constant. But the constancy of this property does not means that the reaction has stopped. Forward and backward reactions also continue after attainment of the equilibriums, and the equilibrium is dynamic in nature. Next is law of chemical equilibrium and equilibrium constant. Law of chemical equilibrium and equilibrium constant. First about the law of mass action. Law of mass action. This law relates the rate of reaction and the concentration of the reactant, and this law was given by Goldberg, and for a general reactions this A plus B form this product, and according to the law of mass action, the rate at which the substance react to proportional to the active mass, or in other words says that the rate of chemical reactions is directly proportional to the product of active mass of the reactant, And according to law of mass action, the rate of reactions directly proportional to the concentration of A and concentration of B. कोई कांस्टेंट लगाएंगे, rate of reactions K is constant and K is known as rate constant. This is the rate constant for the forward reactions. Next is the application of law of mass action to the chemical equilibrium. Application of law of mass action to chemical equilibrium. That consider a general reversible reactions. Consider a general reversible reactions. That is AA plus BB, this forward or backward reactions, CC plus DD. And according to law of mass actions, the rate of reactions directly proportional to the concentration of the reactant, the concentration of A, the concentration of B. Constant लगाएंगे, rate of reactions equal to this forward, the Kf, concentration of A, the concentration of B. Kf is the rate constant for the forward reactions, and rate of reactions directly proportional to the concentration of C and concentration of D की पावर D. कोई रेट कांस्टेंट लगाएंगे, the Kb, concentration of C raised to power C, D raised to power D, and Kb is the rate constant for the backward reactions. At equilibrium state, the rate of forward reactions equal to rate of backward reactions. At equilibrium state, rate of forward reactions equal to rate of backward reactions. This is Kf equal to concentration of A raised to power A, concentration of B raised to power B, equal to this Kb, the concentration of C raised to power C, concentration of D raised to power D. इसको इस साइड में ले आएंगे तो Kf upon Kb and concentration of C raised to power C, concentration of D raised to power D, ये साइड में आ जाएगा. concentration of A raised to power A, concentration of B raised to power B. जो ब्रैकेट होता है स्क्वायर ब्रैकेट, इसको हम कंसंट्रेशन बोलते हैं. दिस इज कंसंट्रेशंस एंड दिस रेशियो इज कॉल्ड K. K equal to the concentration of C raised to power C, concentration of D raised to power D, concentration of A raised to power A, concentration of B raised to power B, and K is called equilibrium constant, and this equation is called law of chemical equilibrium. It states that at a given temperature, the ratio of the molar concentration of the product of the reactant to that the molar concentration of reactant with each concentration term raised to power equal to coefficient has a constant value which is called this equilibrium constant. Next is type of equilibrium constant. types of equilibrium constant, types of equilibrium constant. The equilibrium constant in terms of concentration, this Kc, the concentration of C raised to power C, concentration of D raised to power D, and concentration of A raised to power small a, concentration of B raised to power B. That is the concentration, and this is the equilibrium constant in terms of concentrations. And concentration, this unit is mole per liter. If Kc, this is replaced by this Kp. Kp is equilibrium constant in terms of partial pressure. The partial pressure of C raised to power C, partial pressure of D raised to power D, this partial pressure of A raised to power A, partial pressure of B raised to power B. This is the equilibrium constant in terms of partial pressure, and equilibrium constant in terms of activity. This is in terms of activity. The activity of C raised to power C, activity of D raised to power D, activity of A raised to power A, activity of B, B. This is equilibrium constant in terms of activity, and K are replaced by the mole fraction. This Kx, the equilibrium constant in terms of mole fraction, the mole fraction of C raised to power C, mole fraction of D raised to power D, this mole fraction of A raised to power A, the mole fraction of B raised to power B. This is the equilibrium constant in terms of the mole fractions. Next is a relation between Kp and Kc. A relation between Kp and Kc. The Kp is the equilibrium constant in terms of partial pressure, and Kc is equilibrium constant in terms of concentration. Consider a general reversible reaction, that is AA plus BB reversible reaction, CC plus DD. So equilibrium constant in terms of concentration, the Kc in terms of concentration, the concentration of product, concentration of C raised to power C, concentration of D raised to power D, concentration of A raised to power A, concentration of B raised to power this B, and the equilibrium constant in terms of partial pressure, the Kp, this partial pressure of C raised to power C, partial pressure of D raised to power D, and partial pressure of A raised to power A, partial pressure of B raised to power B. And for ideal gas equation, we know that PV equal to nRT for ideal gas. N is the number of mole of gas, temperature, gas constant, volume, इसको इस साइड में लेकर आएंगे. N by V equal to RT, and N by V होता है concentration, P equal to CRT. For A के लिए partial pressure of A, the pressure of A होगा CA RT, PB होगा CB RT, PC होगा this CC RT, और PD होगा this CD RT. These parameters put here, यहाँ पुट करेंगे इनको. तो PC KP इक्वल टू दिस, KP की जगह जो आएगा, इसकी जगह PC की जगह आएगा C RT की पावर C, CD RT raised to power D divided by the PA, this PA की जगह आएगा CA, the RT raised to power A, और this CB RT raised to power D. इनको हम अलग ले लेंगे इस टर्म में. तो concentration of C की पावर C, this concentration of CD की पावर D, this concentration of Ca की power A, concentration of B power B, and this RT जो है ये C plus D ऊपर माइनस का हो जाएगा A plus D, and this is the Kc in terms of concentration. पुट कर देंगे Kp equal to Kc and this RT, this C plus D minus A plus B. This is delta N. The Kp equal to Kc, this RT, this delta N. Delta N is the number of moles of product minus number of moles of reactant. This is change in the number of moles. This is the relation between the Kp and Kc. Thank you.